Cool. Let's talk a little about units. All right, we will be using, of course, meters, kilograms, seconds, of course. For some of us, we automatically think that way. For the rest of us, you're going to figure it out. Okay. Someone asked me, like, how many meters is that? I don't know. I have to think about it in my mind. All right, now convert. Now, here we go. All right. Quickly now. A meter. Approximately, how long is it? Let's go with Joe, because I remember your name.
0.9 feet.
How much?
0.9 feet. A meter? Oh, yeah, sorry. 3 feet.
There we go. So about 3 feet, yeah? It's all right. I like it. Were you going to say that it's like like a yard is like 0.9 of a meter? Was that what you're thinking maybe? I'd buy that for a nickel. Sure. All right. Yeah, okay, whatever. So approximately. So a kilometer, of course, 1,000 of them, is approximately how far? Just so you can get some visuals in your head. I hate when someone turns in a project or a homework assignment or a test question. The bug was going this fast. Oh, it was. It was, really. It was going Mach 2. Really. Really. Well, how'd you know that, Mr. Graham? Well, I converted, and this many meters per second is this fast. Oh, I didn't do that. Yeah, I know. It really bothers me when people don't think about the logical aspect of their thing. So a kilometer is about how long? Approximately. We'll do the actual measurements later. How much? It's about 3,000 feet. That's actually not bad. Again, I can't fathom what 3,000 feet looks like. So miles-wise, approximately how far is it?
3/5.
It's 3/5. Yeah, I like 0.6. Weird. Good for you, but good for you. Yeah, about 0.6 of a mile. 0.6214 if you want to be precise-ish about it. But whatever. Yeah, about 3,000 feet. I like that. Here's my deal. 3,000 feet doesn't make much sense to me either. Does it to you? At some point, you're like, it's a ways. I don't know. How far did you walk this morning? Literally, I walk 2.25 miles every morning. So 2.25 times 5,280. I could impress you by that, I guess. But it's not really that impressive. Mr. Grimm just rambles around for 2.25 miles at 5 in the morning because, I don't know, it's a good way to get the old blood flowing in the morning and thinking a little bit, okay? But it's the same distance. It doesn't make sense to me to think about things like that. Once they get too big, not going there. Approximately, a kilogram, of course, is mass. Okay, but approximately, what does that correspond to in our units that we're accustomed to? I heard it. Who said it?
2.5 pounds.
Wow, it's about 2.2 pounds. All right, the problem is they're not the same. Yes? This is mass, this is weight, right, which is a unit of force. What's the difference between mass and weight? Do you remember? This is stuff that you should know from way back, yes?
Isn't it that weight doesn't change? I mean, mass doesn't change, but weight changes.
Why?
Gravity.
Because of gravity, yes. And so how would I find one from the other? You remember? Well, my boy Newton would say F equals ma, yes? Where a is the acceleration of gravity, right? So if a fella wanted to know how much he weighs, he would take his mass and multiply it by gravity. And of course, that gravity would be different for every system. For us, it's 9.8, yes? That's not new. That kind of thing, we're just going to like say it, and you're like, oh yeah, I remember that from wherever I'm supposed to remember it from, okay? So, again, in that situation, I like to think of it this way. What is mass? What's mass going to be measured in? What's going to be measured in kilograms? And what's gravity going to be measured in? Well, we're going to talk about this later today, but it's going to be meters per second squared. And this cute little unit right here has a name. It's called a Newton. You mean because of Isaac? That's right. Nice. So 1 Newton is a unit of force. And we'll talk more about this after we get going, but this is kind of some stuff we should maybe have a clue about. So if I said to you, hey, look, 1 pound is how many newtons? I don't know. Let's figure that out. Well, I don't know. So, but I do know this. If I think about this, if I know that 1 kilogram times 9.8, well, so the weight for 1 kilogram would be 9.8 newtons. Which means that 2.2 pounds, 2.2 pounds is equal to 9.8 newtons. Yes? Well, if I divide that out, it looks to me an awful lot like this. If I want to solve for a newton, 1 Newton is going to be equal to something like 2.2 over 9.8 pounds, which is approximately 0.2-ish, or about 1/5 of a pound. Okay? So when you're finding forces later on, and you're like, oh, I got that it was 500 newtons of force put this rocket into orbit, I'm going to laugh at you, because 500 newtons is approximately 100 pounds of force. And I don't think 100 pounds of force is going to quite get that rocket off the launch pad, much less into orbit, yes? So these are the kind of things I will harp on a ton. This is not the only day we're going to do it, of course, by any stretch of anybody's imagination. But I want you to have some, like, does that even make sense? Does that seem reasonable kind of things going on, always. When you're done, don't just turn it in, walk away from it. Oh, that's it, I'm done. Walk away and move on with life, okay? Some of the ones that you should have a pretty good idea from are things like velocity. All right, so this is kind of where we're going to start off. We're going to start off with laws of motion. We're going to start off with that tomorrow and really get into this in depth. But what is velocity? We talk about it all the time, right? Or what else do we call it? Sometimes we call it velocity or speed. Are they the same?
No.
Why not? Oh, nice. This is speed in a direction. Back in my younger, stupider days, I one time asked that question. And we were talking about it. We talked about this being a vector quantity because it has direction. And I said, there's a girl sitting right here. I still see her. I ran into her last summer, but it was pretty funny. We had a nice conversation. I said, you remember that? She's like, I said, suppose Brooke's boyfriend dumped her this morning and left town. What is Brooke going to want to know? And I was waiting for her to say, which direction did he go, right? I was waiting for her to say that. And she starts bawling. Uh-oh. But I'm too stupid to focus in on why is she crying. So I kept riffing on it, right? And then come to find out, he did dump her that morning. What are the odds, right? What are the odds? And I felt so bad, right? So, okay, whatever. What I really wanted her to say was, he left town 55 miles an hour. I really wanted her to know is which direction did he go so I could go find him and kick his butt or go the opposite way or whatever. No, she's balls. I'm like, oh, I felt awful. So it was that was in September. And at the end of the year, or it might have been the next year, I was saying something about in stats class, and she's in the stats class again, and we were talking about it, and it came up, something like this again, and she starts bawling again. I'm like, oh, for God. They got back together. He dumped her again that day. And I'm like, I swear I will never say that again. But it's kind of funny. You laugh at it. You're like, oh, whoops. But when you talk about speed, what is speed by definition? Let's talk about the speed aspect of it. It's the what? What would you call speed? I can't remember your name. Cruise. What is speed? How would you measure it? What is it about? What would it be measured in? What would it be measured in? Nice. Literally, it is distance over time. And specifically, it's the change in distance over time, yes? The change, that's what delta means, the change in distance over time. And literally, that is the very first equation that you ever know your entire life. We usually write distance with x. We'll call it displacement a little bit. That's one of our very first equations. Some people learned it in junior high. The dirt formula, distance is rate times time, right? Maybe someone referred to it that way. It used to piss me off, but whatever, I don't care anymore. And you could also write it like this, x equals vt. Oh, sweet, because they're the same. Okay? Now, something about the book that we're going to use, it's kind of an old book, but I really like it because it was a college book initially. And they actually make you think. All the high school books will literally take this same formula and write it 3 different ways. And ask you to go, okay, man, I want you to memorize these formulas, kids. There's 3 formulas. Here's one of them. And here's another one. And here's another one. Ah! They're the same formula. This is why we take Algebra 2, for God's sakes. Okay? We are not going to be memorizing 87 formulas. In this chapter, chapter 1, there will be 4 formulas. That's it. That's all. Okay? And every problem can be done with those 4 formulas or some kind of hodgepodge of the 2 of them or 3 of them. Okay? Take some from this, slap them together, get my answer. Okay? I am not a believer in doing things 87 ways. I realize that this is the same thing. Me personally, I just memorize that one and know how to solve. Something else. If you ever get stuck on this, and I don't like it, I really don't like doing things this way. Be like, I don't know what formula to use. Let's see, I know the distance and I know the velocity. Can I use this equation? Well, I learned in Algebra 1 that to solve, you need to know everything but one variable, right? So I feel like this one might work. If you have a formula like this fella, which we'll talk about next, well, I don't know when we'll talk, probably next time. Mr. Groom, I know T and I know A, but I don't know anything else. Oh, well, then I guess you can't really use this formula, can you? Well, why not? It's kind of hard to solve for two variables at one time. Oh, yeah. So we'll learn that. We'll talk more about that as we go. It's kind of a huge deal to me. Now, what would I be measuring this distance over time routine? What will we measure that in typically in this class? Meters per second. Beautiful, right? But it could be what? Kilometers an hour? Could be in miles per hour. Okay, they're not the same. They're equivalent though. Okay? You could do centimeters per day, I suppose, if you were like a slug or something, right? That's really tearing things up. Okay? I went 5 centimeters today. Good for you. Good for you. Moving right along. Okay? But again, the book will give you things like the airplane is going such and such miles an hour. Oh, well, I need to have it in meters per second. That's right. Oh, I got to convert. That's right. So, my foot is killing me. So if we were to do that, what would 100 miles an hour be in meters per second? How would you convert that to meters per second? Taylor, how would you go about that? Taylor, I can't believe you got those pictures taken already.
They're uploading. They're just taking forever.
God, you're amazing. That was like supposed to last you like a couple of days of a project.
Well, I just kept turning and saying.
That's why I knew you'd be good for that job. All right, what do you got? Okay, what? Nothing? So let's think about what would we need to know? To get from hours, for instance, to seconds, what would you need to know? 60 minutes an hour. That's good. Probably better know that somewhere. And what else? Well, I don't know. There's 60 seconds in a minute, though, right? Right? Let's just write it down that way, and we'll get there. I know what you're thinking, but you should have multiplied, but you added, but it's fine. We'll get there, okay? So what you're saying is this. These are equivalent. So if you write this out, you go 1 hour is equal to 60 minutes. What I like to do is I like to be able to write them like this, right? Well, if I divide it out, what do I have? Well, I got 1, right? And what happens if you turn 1 upside down? Still got 1, right? Nice. So what a person could do is, well, if I want to go from hours, that's on top right now. If I have 1 hour, if I wanted to convert from hours over here to seconds, I want to convert all the way over here to seconds, well, I need to get rid of hours, right? Well, this right here is a measurement of 1. So the first thing I'm going to do, I'm going to multiply this guy by 60 minutes over 1 hour. Okay? Notice that the one I want to get rid of is hours. I want them to match up on the diagonal. If they're not on the diagonal properly, then flip it over, right? Because it's still just 1. It doesn't change anything. And then you said up here somewhere, you said this was also true. So I could write 60 seconds over 1 minute is also equal to 1, right? But notice that I want to get rid of the minutes. I want to get rid of minutes. So I actually have set it up correctly. The minutes are on the bottom. So if I multiply, again, this is just a fancy way right here. This is a fancy way of saying 1. And if I times by 1 again, but this version of 1, the minutes also cancel out. And you will see that for there are 3,600 seconds is equivalent to 1 hour. That's all we're saying. Okay? Now, once you've done it a few times, you're like, oh, this is really not that hard. It's really not. And after a while, you'll start memorizing some of these because you're like, oh, I memorized it. I've seen that guy before. So first things first. 1 hour, or 100 miles in 1 hour. Well, I now have this cute little thing here that says like 1 hour divided by 3,600 seconds is equal to 1. Right? But if you look at it, the hour, notice the hour, dang it, I did it wrong. I was trying to be fancy, so she'd have to switch it in her head, and I accidentally switched it for her. What an idiot I am. Notice how it's set up. The hours are on the bottom currently, yes? So I want the hour on this guy here to be on the top, which I had up there for you on purpose, on the accident, sorry. What I meant to do was this. What I meant to do was write it like this. Okay? And you'd be like, oh, I have a conversion. It's just upside down, yes? So I flip it over. Cool. So now what will you have? You'll have 1 hour over 3,600 seconds. And notice that the hours cancel off. Whatever you're going to get now is miles per second. How many miles are you going to be going per second? If you're going 100 miles an hour, that's moving right along, right? No one's going to question that. But how many miles in a second are you going to be going? Think about that. A mile every second. Think about how far that is, right? You went from the stoplight out here, I don't know, almost to Columbia Boulevard, right? In 1 second. I don't think so, Mr. Groom. That's too fast. That's right, because what is 100 divided by 3,600? It's like 0.03, yes? So you're going like 0.03 of a mile every second. That means you're not going a mile. That's good. Yeah, you're a tiny little fraction of a mile. And so that's good. But we're not done yet. We need to get rid of this. We need to get rid of this miles garbage. We need a conversion. How many meters in a mile? Do you know? Off the top of your head, Mr. Birdsell? No? No? Turns out that there's roughly, for the purposes of our argument, there's 1,600 meters in 1 mile. You could get a little more technical than that. It's not too far off. I think it's 1609 point something. But for the purposes of our discussion, 1,600 is swell. So look, if you on it, there it is. Bam! Yes? Is that the right direction? I think it is, isn't it? Because if I do it like this, 1,600 meters, 1 mile. Look what happens, friends. My miles cancel off. Whee! And so if you multiply across the top, you'll get 1,600 times 100 divided by 3,600. And what's left on top? Meters. And what's left on the bottom? Seconds. Nice. Punch that out if you would, please. What is that? 160,000 divided by 3,600. Here, quick. Where's my Desmos? Come on. If you're not using if you're not writing something down, please use a Desmos. Help us out a little bit. People who are writing crap down, they don't need to do the calculations. No, that's fine. Again, just getting into it today. We'll be doing more tomorrow. Just kind of see where we're at. Have you seen this before? Your unit conversions, yes? Presumably in chemistry, you feel pretty good about them, I hope. If not, we will make it till you do. Okay? What do you get? What do you get? 44.4 meters per second. Am I right? Yeah! Mr. Grimm, how do you know? Because I've done this a few times. Okay? 44.4 meters per second. Now, this is a big deal to me. It drives me bananas when people do some weird conversions. So think about this for a minute. What would 50 miles an hour be? Like, we already have this out here, but what would it be? Well, 100 was 44, so 50 ought to be 22, right? So people will say things like, it makes sense, Mr. Grimm, it's 44 miles, for 100 miles an hour, it's 44 meters per second. On the exact same problem or lab, they will convert 25 miles an hour and say it's 50 meters per second. No. Not even going to happen. Okay? Just pay attention. Again, not hard. Just pay attention to it. Okay? So we'll be doing some of that tomorrow. We'll also be talking about the difference between distance and displacement tomorrow. I think it's sad. I think it's very sad that you kids, probably for the most part, have never seen Ferris Bueller's Day Off, one of the greatest movies of all time. So they take out this Ferrari, they put a bunch of miles on it, and they think they're going to back the miles off. Doesn't work that way. The difference being they parked the car exactly where it was when they started. Okay, like when you go home tonight, you'll have 0 displacement from where you started from. If you're a person who cleans up after yourself, whatever you use, the milk will be back exactly where you took it from. If you're one of these slobs, the milk will be on the counter, and so it will have displacement from where it started from. It's not back where you put it. But the distance is not 0. Okay, they drove that car a couple hundred miles that day. Okay, and so the dad was going to know it was a god awful mess. It's a great movie. You should watch it sometimes. Netflix it or whatever you do, you children do these days. It's a good movie. I highly recommend it. But we'll be talking about that tomorrow, and we're going to kind of see where we go from that. There will be several different labs this chapter. We're going to use a program called Physics Tracker. I love it, and it's not very hard. Okay, and for those of you that are constantly on your phones playing games sort of things, it is the easiest program in the world to run. That said, there's going to be somebody in this room who it literally hates. I don't know why, it just will hate you, and you will come in crying, probably literally shedding tears because it hates me. It literally does. Yeah, you're right. I don't know why, but we'll be videoing each other, walking. That's a big head. We'll be videotaping each other as we walk across the commons, let's say. And then we'll be using this physics tracker to see how fast it is you're traveling, what your acceleration is, all that good stuff. We'll be talking about some of those relationships in the next few days. Again, the tracker is so easy to run, and yet every time somebody, it hates it. Literally, I have no idea why you can't do it, but as soon as I tried it, works perfectly, and I don't know why. I don't know. And I wish I could tell you, oh, it's because you did this. I don't know. I think there is a little person there that hates somebody in my class every time. But it is a fun little program. We'll be analyzing a lot of video this way this year because, let's face it, we all have phones and we like to use them. Okay. By the way, there's a person in this building who hates the fact that I use phones as much as I do.